Hi, 3.3 Measuring Dilations. Today we're going to know when figures are dilated by a scale factor of k, all lengths in the figure are multiplied by k. We're also going to practice constructions using a compass and a straight edge in order to dilate a figure. So if you don't already have a compass and straight edge nearby, go ahead and pause this video and get yourself a compass and a straight edge. It says using a compass or ruler, dilate triangle FGH using center C and a scale factor of 3. So if you visualize it, we're trying to scale this figure from C. So it's going to grow from that center out 3 times. So I do think that using your compass is the most efficient way to do it. You could use a ruler depending on how good you are at using your ruler to measure. But if I look at the inches, between the center of dilation and even G, it's not a very nice inch mark. And then we can check and see if it's a very nice centimeters length, and it's actually pretty nice, 1.5. That one's not terrible. But still, I'm going to teach you how to do it today using your compass. So what you're going to do is make a connection between your center of dilation and each vertex and extend it out so that we can increase the size of this figure 3 times. Now, we can use our compass to be our measuring tool, and we can use our anchor on the center of dilation out to 1 vertice, and that counts as 1 of the units of the factors of 3. Then I have 2, and now I have 3. Oh, I barely made that line long enough. Now we do the same thing between C and F. So open your compass and make it the length between C and F. That counts as 1 of the lengths. 2 and 3. And then our final one between C and H. Open your compass. So that counts as 1 unit. 2 and 3. So now each of these segments, so see I've got 1, 2, 3, this intersection here is now G prime. And this intersection here would be F prime, and this intersection here would be H prime. And when we connect them together, we can see our triangle that's been dilated by a scale factor of 3 from that center C. So now it says use a compass to dilate the triangle FEG using center C. Again, it's on the interior of the figure, but this time they want us to use a scale factor of 3/2 or 3/2, or the same thing, or 1.5. So we're going to increase its size by 1.5. So what you do again is to connect it's an enlargement, so we're going to connect our center of dilation to each vertice. And I'm going to extend it out because we're making an enlargement. And now if I want to go 1.5 times, if I look at this figure right now, I already have the unit of 1, but what I'm missing is the additional half. So it's gonna land this is an eyeball mark between C and G, that's about the halfway mark. So it's gonna land about there, that's where G prime is gonna be approximately. So between C and F, that's the halfway, so F is going to move to about right there, and E is probably gonna move to maybe about right there. So to get the midpoints, of course, again, you could use a ruler, but some of us not so good at using rulers. You can use a compass to find the midpoint between each of our endpoints and our center of dilation. So place your anchor on your center and open your compass more than halfway between your center and your vertice. And we're going to make our perpendicular bisector construction. So now if we connect those, we don't need to draw the whole line. I just need the midpoint location between F and C. So now that spot right there is the midpoint, and we're going to use that midpoint to make our 1.5. So remember, C to F is the 1, and now I just need the half. So from the midpoint to vertice F, and now I can mark that up here. So that's our new F prime. So 1 unit and a half, 1.5. So now we're going to do the same thing between C and G and C and E. So we're going to make our perpendicular bisector between C and G. So there's our midpoint between C and G. I'll go back and measure it in a second. I'm just going to finish my perpendicular bisectors. So now let's do our perpendicular bisector between C and E. Line up your intersections and get your halfway. So now I've got my halfway mark. If I had connected those 3 points there, I would have had a triangle that is half the size, but we want one that's 1.5 size. So now I take that half mark and mark it right there. There's my new G prime. And now I'm going to use my compass to measure between the midpoint and E and mark that down below. So now here's G prime and E prime, and we can connect those to see our triangle that's been enlarged by 1.5 times. So not double, but 1.5. From our center C, which happens to be on the interior of the triangle this time. Okay, it says triangle P prime, Q prime, R prime is a dilation of PQR, this triangle here, using center C and a scale factor of 1.5. Is triangle P prime, Q prime, R prime larger or smaller, or an enlargement or reduction from triangle PQR? Explain how you know. Well, this is our original, and we want a P prime, Q prime, R prime that's a factor of 1.5. We just saw it on the last page. That's going to be larger, an enlargement, because 1.5 is greater than 1. What is the length of segment P prime, Q prime? Explain how you know. So P prime, Q prime is going to come from the corresponding side length of PQ. So the original length is 5, and I can multiply it by my scale factor in order to get the final length. 5 times 1.5, and 5 times 1.5 is 7.5 units. So if I increase this triangle by 1.5, this long leg, this long side of the triangle will become 7.5 units long. Where would you place points along the ray in order to make a scaled copy of the triangle with different scale factors? So here's our center of dilation O, our triangle ECF, and they're telling us that this length between O and E is 8. So where would we place, these points, thinking about just EO in particular, since that's the only unit that we have? If I were going to make it twice the size, how long would it be from O to E? Well, our original length is 8, and I would double it, so then it would be at 16 units long. Point E would be at 16 units long. Then how about half the size? Well, 8 times a half, or 8 divided by 2, that's going to be right there at 4 units long. How about if I want to make it a fourth of the size? 8 times a fourth, you do 8 times 1, which is 8, divided by 4, and 8 divided by 4 is 2. And you can see that if you break 8 into 4 chunks, it's going to be a 2, 2, 2, and 2. So then the fourth would be right there at 2. How about 3/4 the size? 8 times 3/4. 8 times 3 is 24 over 4, so that's going to be at 6 units. Again, thinking about breaking it into fourths, if I want 3 of the fourths, 2, 4, 6, it would be right there at 6 units. Triangles ABC and DEF are similar. Which statement is correct? Select all that apply. Well, they told us that ABC and DEF are similar, but they didn't give us a diagram. So let's draw our own diagram. Let's draw a small ABC and a similar, larger DEF. A, B, C, and D, E, F. And now we want to know which of these proportions that are already set up for us are correct. Let's check the first one. BC is to EF as AC is to DF. That's true. AB is to DE as CA is to FE. That's false. CA would be to FD. How about this one? AB is to EF. Oh, that's already not correct. I've got my long leg. AB is to DE. How about the last one? CA is to FD as BC is to EF. That one is also true. So A and D. All right, 2 polygons are similar. The 2 triangles are similar. They're not in the same orientation. I can see I've got a matching angle between those 2 side lengths there. You can also see that the longest sides are kind of facing each other. So I'm going to use a tick mark. This 39 corresponds to x minus 6. And then the shorter side of 24, the shorter side of 24 here matches with our shorter side of 18. And then this medium length, 27, matches with y. So it says find the values of x and y. Well, x has a match of 39. It's got a minus 6. Yeah, let's do that one in a second. Let's start with y. So who is y proportionate to? Y is proportionate to 27. And then now we get to choose which other 2 lengths we'd like to compare, but the only other one that has a value on it is 18. So y is to 24 as 18 is to 20, I'm sorry, let me say again. Y is to 27 as 18 is to 24. And now I've got a proportion where I can cross multiply. So y times 24 is 24y. And 27 times 18 is 486 divided by 24. And y is equal to 20.25 or 20 1/4. Now we want to get our value of x, so let's do a comparison. X minus 6 is proportionate to 39. As again, I'll use the same proportion as before, 18 is to 24. Now when we cross multiply here with the x minus 6 and the 24 applies to both the x and the 6. So I'm going to write it using parentheses. 24 times x minus 6 equals 39 times 18, and 39 times 18 is 702. And now to get rid of the parentheses, I need to apply the 24 to both the x and the 6. So we get a 24x minus 144 equals 702. Plus 144, we get a 24x equals 846. And divided by 24, and x equals 35.25. Thank you.